We are in the same chapter. We are in the same chapter. So we don't have a new cover page. We just took a test on half of it. The second half is on circles. So we're starting with circles, and anytime we're dealing with circles, we're dealing with pi. And pi, when I say what is pi, a lot of times I just get that 3.141 ... And if you want to see all of them, they're all right there. But it goes on forever and forever and forever and forever and forever and forever. But when I ask what is pi, what I'm asking for is this. Pi is a ratio. Pi is a ratio between our circumference and the diameter. So it's the circumference to the diameter. And what I think of when I look at circumference, I'm actually thinking length. I'm thinking length. Because circumference is that total length around our entire circle. Circumference you can kind of think of as, so square we have area and we have perimeter. Circumference is basically the perimeter of a circle. It is how long does it take to get around. Well, on these two circles, we're going to go ahead and put that. We're going to say our circumference is that total distance all the way around. That is our circumference, is that length all the way around. Now our diameter is just that line. We've done plenty with diameter. It is this line right here. It's the line that goes all the way through the center. So this is my diameter. About right on the side. And our radius is just half a diameter. That right there would be my radius. Bless you. So radius is just half our diameter. Or in other words, our diameter is 2 times our radius. So if I say the radius is 6, what's the diameter? You just go 6 times 2. Boom, your diameter's 12. All right, since pi is just the ratio of the circumference to the diameter, our circumference, let's skip to our circumference with diameter. We're going to skip to that middle one. Our formula for a circumference with diameter is circumference equals pi times our diameter. Which means if I'm using my radius, we're going to have this equals 2 pi r. So once again, if my circumference is pi times diameter, if I'm using radius, I need 2 of them to equal my diameter, right? 2 times r equals the diameter. So it really is the same equation. It's just one has radius, the other one has diameter. All right, area of a circle. Area of a circle. We're going to go ahead and put a cap A for area. Area of a circle is, does anyone know the area of a circle offhand? Stephen?
Pi r squared.
It is pi r squared. We have to pretty much know those area and circumference ones like the back of our hands. All right, we're going to be using them a lot throughout this section. So we have to know how to find the circumference. We have to know how to find. Below is basically just a rehash of what we're doing. Do you have a question? Yeah, sorry.
Yeah, sorry, is the squared for the whole, the pi and the r, or just r?
No, that's a great question. It's just the r. If I wanted both of them,
You put it in front.
I would choose a parentheses, but it's a good question because I could have forgotten them, right? Yep. It is pi times our radius squared. So our radius is 6. It'd be 6 squared, and then multiplied by pi. All right, moving on. This is the same thing we have right above. I want to find circumference. This says, what am I given? I am given radius. So that means we're going to use the radius formula for circumference, which is just that 2 pi r. If I'm looking for the circumference and I'm given diameter, we're just going to use the equation pi times d. And you'll see in the notes when we're going through it, I'll usually put the d in front because it's going to turn into a number. and a number really goes in front of pi, right? You don't ever say pi times 3, I'll say 3 pi. So a lot of times you'll see me just shifting this in front. So if you shift it in front, I'm not going to take any points off because you put the d in front. All right, next one is area. If you're given radius, we already said that's pi r squared. If I'm given diameter, we have to divide that diameter in half in order to get my radius. So that's just going to be pi times diameter divided by 2 squared, which is still pi r squared. Diameter divided by 2 squared is r squared. Just know those, guys. Practice them. All right, let's do some examples with them. We have what is the area and circumference of a circle with radius 10. So we are given our radius. I'm looking for circumference. I'm looking for area. Let's start with area first because I think that's the best known one. Area equals pi r squared. Our radius is 10, so it's pi times 10 squared, which is going to equal 100 pi. If we had units, it'd be units squared, but we don't, so we're just going to have our area equals 100 pi. Circumference. Circumference with radius is 2 pi r. Our radius is 10, so we actually have 2 times pi times 10. But because I'm multiplying, we can use commutative property to switch these places, so I can just do 2 times 10 to give me 20 pi. So our circumference equals 20 pi. Rough stuff, right? Yeah. Our next one says, what is the diameter of a circle with a circumference of 16 pi? So we're doing circumference. Circumference, I'm dealing with the diameter, so let's go ahead and say our circumference equals pi times diameter. Yes?
So why couldn't we do like 3.14?
Because we want exact answers.
Also,
3.14 is an approximation. It's kind of like when I do square root of 3. I wanted a square root of 3. I don't want the decimal approximation.
okay. And I know there's like a fraction that's like 22 over 7 too. If that was like in a case where we had to
We'd leave it as a fraction 22 over 7.
Oh.
Yep. So try not to use your calculator in a section where we're sticking with pi's and square roots and stuff. All right, so we have circumference equals pi times diameter. Well, it says the circumference is 16 pi. So we're going to put in 16 pi in place of this c, which equals pi times d. You just divide both sides by pi. In other words, our pi's just cancel out. I'm left with my diameter equals 16. What was that? It is a rough question. Hopefully you've seen all of this or are privy to this knowledge. Because now we're going to throw something a little more new at you. This next section is a little bit more new. And that is finding the area and circumference of a shaded region. All right, we're finding the area and circumference of a shaded region. What do I want to start off with? Let's start off with how much of that circle is actually being taken up. Yeah. A fourth. It looks like a fourth, right? It is a fourth. How do I show it's a fourth? Yeah.
Wait, is it because of the right angle?
It is because of the right angle. So if this is a right angle, what's the degree measure on this arc? Amber?
90.
It is 90 degrees. So this measure right here would be 90, let's just put 90 degrees. What's the total measure around an entire circle? Yeah.
360.
So if I wanted to know how much of this is being taken up, I would just do 360. Actually, let's do it the other way. I'm going to do 90 divided by 360 so I can get that fraction, which is going to simplify to 1/4. So this section right here is 1/4 of the entire circle. It is 1/4 of our entire circle. Well, if I know that, can't I just get the total area, multiply it by 1/4? Get the total circumference, multiply it by 1/4? Does that make sense? So let's do that. Let's get our total area and circumference. Yeah?
For circumference, don't we just look at it, it says 90.
No, that's our degree. I want to get the actual measure. Like if I had this circle, right?
Yes.
It has 360 degrees.
Yes.
If I have a bigger circle, say the one right here, do these have the same circumference?
Oh, no.
No, because their circumference is actually measuring it. So degrees are always going to stay the same for a circle, but your circumference will not always be the same because you have different sized circles. So we're going to find our totals. Let's go ahead and find our total area. Can someone tell me how to find the total area? Sabrina.
So the pi r squared, so you do area equals half, 1/4 of area equals.
Yep, I'm doing the total of the circle. We'll do that 1/4 in just a second.
Oh, okay. So area equals pi 10 squared.
10
so
squared.
Area equals 100 pi.
100 pi. Yeah, perfect. All right, can someone tell me how to find my circumference? Amber?
C equals pi times the diameter.
Okay, pi times the diameter, and our diameter would be 20. So I'm just going to change that because we were given the radius. I'm just do, but you're fine doing that. I wouldn't take any points off. That's great because you already did the 2 times 10, but that's going to equal 20 pi. So that's the total. Now let's do the portion, which Sabrina already started off on, right? You said let's just take 1/4 of it. So the portional area, I'll call it A sub P, is going to be 1/4 of that 100 pi, which equals 25 pi. Our perimeter of our portion, I'll call it P sub P, is going to be 1/4 of that 20 pi, which is going to equal 5 pi. So that's my area. That's my perimeter of that little section. And that's actually what we do. We figure out how much of the circle we're looking for. We find the total area and multiply it by that number. And we do it in this equation here. So this is not my area, but this is going to be my length. Or so generally we just say, what's the length? What is the arc length? And it's going to be x divided by 360 times 2 pi r. So what's going to be giving us here? This is the percent of our circle. And this is just our circumference. So using this exact same thing, our area of the sector, or the shaded region, would equal x divided by 360 times pi r squared. But we're mostly dealing with just that arc portion today. But area isn't that big of a leap, is it? Just multiply the percent of the circle. All right, let's go ahead and do those 2 problems right underneath. And we should have plenty of time to start our homework. All right, this says, in circle A, inscribed angle BCD equals 36 degrees. So let's draw this. Let's draw it. Inscribed angle is one touching basically the back of the circle. And this is BC to Z. That's a cool way to say it. And this is 36 degrees. If that is 36 degrees, what is the measure of the arc in degrees? What is the degree measure of it? Stephen? 72. Yep. So we're going to do 2 times. That would give me 72 degrees. Cool. All right. Then it says if the radius is 24 centimeters. So that means if I would draw like a center thing to here, we'd have 24 centimeters. Doesn't matter where we put it because we're going to use that equation. It asks, what is the arc length of BC? Well, arc length of BC is going to equal what percent of this circle is taken up by this 72%? To come up with that, or 72 degrees, we're just going to do 72 divided by 360. Because there's 360 total degrees around, I'm only taking up 72, so the percent of the circle that's being taken up here is just 72 divided by 36. And since we're looking for the length of it, we're just going to multiply. Length is our circumference, so that's going to be 2 pi r, or 2 pi times my radius is 24. Ooh, what did I do?
We're looking for BC, and that's trying to find BD.
Oh. That's a good point. I don't think I wanted to do, but we could. Let's just change it to BD. Let's just change it to BD. I don't want to make this anymore. I just want a nice, easy. So we're going to change that to BD. Thank you for pointing that out. Yeah, because originally I had it set up like this, right? Which wouldn't be that hard. We would just divide by 2, but I just want to leave it with the 72. So we're going to change that to BD. So we have our arc BD equals 72 divided by 360 times 2 times pi times 24. We're going to leave this as best we can as, well, this is going to come out as a decimal, but a nice decimal comes out as 9.6 pi. I started off saying we should leave everything as fractions, but these are too big. We're just going to put them as decimal. I'll give you a chance to plug that in because Hannah looks angry at it.
No, I got something like completely different.
Oh, okay. I think the easy way to do these is just do 2 times 24
Pi and yeah.
times 72, and then at the very end divide by 360, and then attach your pi. Don't put pi into your equation because your calculator is going to round pi. So leave pi out of your equation in your calculator because we're going to leave it as pi. Yeah, Sabrina. Yes, at the end. So I'd plug all these numbers into my calculator minus pi, and then at the end plug pi in. Sabrina?
What do you mean by length? Because like
Length is what is the actual? So this is 24 centimeters.
yeah.
If I was to actually take a tape measure out, what is the length of this?
And that's the formula.
That is the formula, yeah. Because our formula says, remember how circumference is also length? Circumference is basically perimeter. You remember perimeter of a rectangle? Was it just measured all of the lengths of a rectangle? Circumference is our perimeter. It is, if I took a tape measure out, what in centimeters is going to be that length? So that's why it's just the percent of the circle times our circumference will get you that little length. Okay? So if we look here, Sabrina, see this 2 pi times 24? That is our total circumference, that'd be the length all the way around the circle, would be 2 pi times 24, so it'd be 48 pi. And I think we had maybe centimeters. Now if I figure out what percent of this circle is being taken up, we drop it down to 9.6 pi, and I should actually have centimeters attached to that. Does that make more sense, Sabrina?
Yeah.
Okay. All right, in circle G, measure of JR equals 108 degrees. So let's go ahead and do that. Let's go ahead and come up with a J and an R and say that is 108 degrees. And it is circle G, so let's go ahead and label that. And the length of JR equals 9 pi centimeters. So the length of that is also 9 pi centimeters. So we have the degree and we have the length of it. Let's just real quick write down the formula for this. So the arc JR is going to equal our x divided by 360 times our 2 pi r. Well, we fill in the information we know. we know the length. That is JR. So in other words, we could say length of JR is going to be 9 pi. So let's put 9 pi in that place. Is going to equal, we know the degree measure is 108. So of 108 divided by 360 times 2 pi r. R is the only thing I don't know. R is the only thing I don't know. What we're going to do next is we're just going to enter calculator, type in 108 divided by 360 and multiply it by 2. So type in 108 divided by 360 and multiply that by 2 and tell me what you get out. Sabrina?
For the total answer, I got 15.
Yeah, it's going to turn out 50, but I just want to do a step. Yeah, what'd you get? You got 0.6, yep. So I'll have 9 pi equals 0.6 pi r. Well, we're going to divide both sides by 0.6 pi. Divide this side by 0.6 pi, so our pi's will cancel out. Our 6 will cancel out here, so we just have to do 9 divided by 0.6, which Sabrina already said is 15 centimeters. I can't run out of room. But it comes out to 15 centimeters. All right, so up until now, we only dealt with degrees. We said JR was 108 degrees. Now we're going to throw a measure in there, just like we did here. We'll have centimeters and the total length of it. We're talking circumference. All right, questions on any of that? Your big formula for today, you sure already know area and circumference. Your big formula is this one. All right, the area one's good to know, but that's the big one for the homework. That one's our big one we need to know from this lesson. All right, go ahead and get started. I do want to say on the homework, on my answer key, I actually ended up just putting the solution to number 13. It's a nice, hard problem. It takes lots of thinking about it. So I didn't even put the solution up. I only have the answer. I didn't put my work up there. We'll talk about it tomorrow, how to actually do it. I couldn't think of a good way to actually put it where it didn't look more confusing than how I set it off. So I just have the answer. See if you can get it.